Now would be talking about the intuition to blue. Okay, that is your best linear unbiased estimate. Now what do you actually mean by B, which is best? What is best? Okay, what is best? Best would mean this variance of beta hat from beta. Okay, this is the variance which is given to you. Now it will have a smallest variance. Okay, I'll be also proving blue, okay, in some other recording. In this recording it is only the intuition to blue. Okay, well, this is your blue. Okay, well, second is your U. I'll talk about L, but U is your unbiased. Okay, so it would mean this, that suppose you have your distribution over beta. Okay, now suppose you flip a coin and you flip a coin for 10 times. Okay, you get head times 6 times, your 7 times, you get even 4 times, 3 times, and so on and so forth. So on an average, I mean, this is the value of your beta hat. Okay, and this is there, and you would say this, that E of beta hat is equal to beta. Okay, so on an average beta hat is equal to the true value of beta. Okay, this is actually the sampling distribution of the estimator beta hat, that is the distribution of the values taken by beta hat in the repeated sampling experiments. Okay, so I mean, in one experiment you have flipped the coin for 10 times and you got you got the head for 7 times, and then in the same experiment then you again flip the coin for 10 times and you get head for 6 times, and so on. So this is your repeated sampling experiments. So beta hat to be distributed symmetrically. Okay, and you would assume this, that your E of beta hat is equal to the true value of beta. So in this situation we say this, that beta hat is the unbiased estimator of beta. Okay, so beta hat is the unbiased estimator of beta. Well, take up the another distribution also, say like this. Okay, and say this is over beta star. Okay, E of beta star is also equal to beta. So on an average E of beta star is also equal to beta. Okay, but both of them are unbiased. That is, on an average your beta hat is also equal to beta, the true value of beta, and on an average beta star is also equal to beta. Okay, but this one, your white one, your beta hat, is on an average, it is farther from the true value. Okay, so its variance is larger. Okay, so your beta hat has a larger variance than beta star. Okay, both are unbiased, both are linear, but you would want to choose the estimate which have a smaller variance. Okay, which has a smaller variance. Okay, other is of course your linear. Okay, now linear would mean this, that linear is of course it would mean, say for example, your beta hat is equal to summation of alpha I yi. Okay, which is your summation of xi yi upon summation of xi square. So alpha I is of course it's a function of some x's. Okay, it's a function of x's, which is this, which is your xi upon summation xi. Okay, so what you're talking about is that that these are your linear estimators. Okay, so these are linear estimators, and the other important point is that when you're saying that these are the best estimates, okay, what you actually mean by best is that you're talking about being best in the class of linear estimators. Okay, well, there could be some non-linear estimators also which are better than this linear estimator. Okay, we're not saying that OLS is the only estimator which is best, no. Okay, but what we are saying is that under the class of the linear estimators, okay, this would be a best estimator. So when you say best, you mean something. Okay, and what do you mean is this. Okay, so I hope this is clear. Thanks.